In certain engineering traditions around the world, engineers wear a ring, named the iron ring. This ring symbolizes their craft, their discipline, and their identity. It reminds them of who they really are and what they've committed themselves to. This tradition motivated us. As a class, we asked ourselves, what if our graduation medal carried the same meaning, but spoke a language we learned? Not just an engraved medal around our neck, but something that contains signals and circuits. My name is Tom Perrin, an electrical and electronic engineering student from Old Technical University, and our class and I designed exactly that. The entire medal was designed from scratch. The PCB was laid out in KiCad from the schematic capture through the routing process to the manufacture preparation. The outer metal casing was also modeled in Autodesk Inventor. It was designed to house the PCB so that it can be easily worn around the neck. Today, we are going to look at what motivated us, the constraints we went through, and what it's actually about.
At the core of the medal is an RP2040, a dual-core Cortex M0 Plus microcontroller. Running custom firmware we wrote specifically for this project. I am in the person of Elizabeth Kanda, and we are proud to say Raspberry Pi Foundation has already come on board, sponsoring 50 of these RP2040 microcontrollers, one for every graduating student in our class. Program storage is handled by SPI Flash memory, connected via SPI interface to the RP2040 microcontroller. This holds both the firmware and something very special, a unique waveform dataset for each student. The system also runs off an external crystal oscillator, giving us the timing precision we need for stable, accurate analog signal reconstruction. Now, this is what makes this medal unlike anything you've seen before. Each student's name and personal details are encoded into XY coordinate points stored in the firmware. The RP2040 microcontroller streams those coordinates to a DAC, a digital to analog converter, which brings out two simultaneous voltage signals, one for x-axis, one for y-axis. The medal exposes three parts: X out, Y out, ground. Connect those to an oscilloscope in XY mode, and the student's name appears on the screen as a text in a waveform, and that is an engineer's signature.
Yes. Earlier on, we designed a USB connector sitting directly on the medal to help us program it. But later, after modeling the outer medal casing in Autodesk Inventor, we saw that it would give us a problem by hindering us from connecting a USB cord directly into the connector.
It would have been completely inaccessible. So we rethought the approach. Instead of a USB port connected to the medal, we developed a pogo-pin interface, a secondary programmer board that connects test parts to the medal through loaded spring boards. This keeps the medal clean, compact, and enclosed.
We also had people question, why don't we just go with the traditional engraved medal, or just put behind the QR code to help other people scan and know the details? Honestly, we understood that.
But the whole point was to build something that demonstrates, something that functions, something that only an electrical and electronic engineering student would think to make.
We are very grateful to the Raspberry Pi Foundation for sponsoring 50 RP2040s. This means that each student in our graduating class is going to get a medal. Now we are done with the design, and we are yet to bring it to its physical form. We are reaching out to PCBWay because we believe that this is the exact kind of project that represents what PCB manufacturing can enable.
PCBWay's reputation for fabrication and assembly support makes them fit for a project like this, where signal integrity, compact routing, and manufacturing quality would determine how the product performs. It started as an idea for our graduating class.
And with the right support, we can bring this to light. We will be very honored to do this with you, PCBWay.
Thank you.